The universe, in its infinite and occasionally sadistic wisdom, had established certain non-negotiable requirements for any species hoping to graduate from interesting organic matter to actual civilization. These requirements were not suggestions. They were not guidelines open to creative interpretation. They were the cosmic equivalent of building codes, and violating them typically resulted in extinction rather than a stern letter from the inspector. At the top of this list, carved into the metaphorical bedrock of galactic development theory, sat one fundamental truth. Not metaphorical fire, not the fire of passion or the flames of determination, but actual, literal, chemical combustion fire. The kind that burned things and produced heat and made raw meat significantly more appealing to digestive systems that had not yet evolved the fortitude to handle parasites with names longer than most doctoral dissertations. Every sapient species in the known galaxy had discovered fire. Every single one. The Krell had discovered it. The Thaxians had discovered it. Even the Blorgnoids, who were essentially sentient moss with delusions of grandeur, had managed to figure out combustion. It was the first rung on the ladder of technological civilization, and there were no alternate routes, no elevators, no stairs. You either climbed this ladder or you stayed in the trees. Sometimes literally. Losing fire after you had discovered it was not just catastrophic. It was extinction with a footnote. The galactic historical records contained exactly 47 documented cases of species losing their fire-making capabilities due to environmental catastrophes. Those same records contained exactly 0 instances of those species surviving. The mathematics were depressingly simple. No fire meant no cooked food. No cooked food meant parasites, malnutrition, and a rapid return to the ecosystem as fertilizer. Natural selection was not known for its mercy. The academic consensus was absolute. Fire was not negotiable. This was not arrogance. This was simply observable reality backed by 47 extinction events and approximately 12,000 peer-reviewed papers. The universe had rules, and species that broke them stopped being species rather quickly, which made the situation on the third planet of an unremarkable yellow star in an unfashionable arm of the galaxy particularly interesting to the Vorathi. The Vorathi were anthropologists in the way that hurricanes were weather patterns, technically accurate but missing several important nuances about scale and destructive potential to existing paradigms. They had been studying primitive species for approximately 40,000 standard years, which was either impressively dedicated or suggested they needed better hobbies. Possibly both. Their current assignment was Earth, a small wet rock that had recently developed its first genuinely interesting species. The humans had discovered fire approximately 1 million years prior, give or take a few 100,000 years. The Vorathi were not particularly impressed. Most species discovered fire and then proceeded to spend the next million years making incremental improvements to hitting each other with increasingly sophisticated rocks. Humanity appeared to be following this pattern with predictable mediocrity. The lead researcher, whose name translated roughly to Distinguished Professor of Why Primitive Species Do Stupid Things, had been ready to file Earth under standard development, check back in 50,000 years when the atmospheric readings started producing numbers that made the instruments question their life choices. The planet was cooling. Rapidly, something had happened. Some combination of volcanic eruptions and atmospheric disruption that the monitoring team had not predicted because they had been too busy arguing about lunch. The sun was disappearing behind a veil of ash and particulates, temperatures were plummeting, and most critically, most catastrophically, fire was becoming impossible. Combustion required oxygen, fuel, and heat. Earth's atmosphere was rapidly losing its enthusiasm for providing any of these in sufficient quantities. Lightning strikes that should have ignited forests were producing nothing but ozone and disappointment. The ambient temperature was dropping below the threshold where natural fires could sustain themselves. Existing flames were guttering out like candles at the end of a particularly depressing birthday party. The Vorathi monitoring station went from academic boredom to frantic excitement in approximately 47 seconds. This was it. Extinction event number 48. They were going to witness it in real time with proper documentation and multiple camera angles. The grant money alone would be extraordinary. Distinguished professor dispatched observation drones across the planet and settled in to watch humanity die. The academic paper was already writing itself in his head. He even had a title, Extinction Event Analysis, Earth Third Planet, Standard Pattern 48 Alpha. It was not creative, but it would publish. The first 3 months proceeded according to every model ever constructed. Human populations began dying. Not immediately, which would have been merciful, but slowly, wastefully, in the agonizing way that extinction tended to proceed when it was not hurried along by asteroids or supervolcanoes with ambition. Without fire, humans could not cook food. Without cooked food, their digestive systems, which had spent 1,000,000 years becoming optimized for eating things that had been subjected to chemical transformation via combustion, began failing with impressive consistency. Parasites that had been manageable became deadly. Bacteria that would have died screaming at 60 degrees Celsius were instead throwing parties in human intestines. Malnutrition stalked populations that had plenty of food but no way to make it digestible. The Vorathi drones documented everything with the dispassionate precision of scientists who had seen this exact scenario 47 times before. But humans were not dying fast enough. Distinguished professor noticed this first. By month 4, human populations should have been down by 60%. They were down by 30%. By month 6, the species should have been in terminal decline. Instead, humans were still existing with what could only be described as stubborn spite. They were adapting, badly, inefficiently, in ways that would make any evolutionary biologist weep into their taxonomy charts, but adapting nonetheless. Humans had started eating raw food. Not occasionally, not as a desperate measure, but systematically. They were consuming meat that had not seen fire, roots that had not been roasted, vegetables that remained uncooked, and presumably offended by the whole situation. More bafflingly, they were surviving it. Not thriving, not comfortable, but stubbornly refusing to die on schedule. Their digestive systems were failing, yes, but slowly enough that some individuals were lasting long enough to adapt. Populations were migrating toward the equator, seeking warmth that no longer came from controlled flames but from a sun that was itself struggling to penetrate the atmospheric mess. The Vorathi research team was confused. Confusion was not an emotion they experienced often. They had models, they had data, they had 47 previous extinction events that all followed the same pattern. Earth was deviating from the script, and distinguished professor was developing what humans would have called a stress headache, but which in Vorathi physiology manifested as an uncomfortable tingling in his tertiary neural cluster. They should be extinct, his assistant observed unnecessarily. I am aware, distinguished professor replied. I have the data. I can read numbers. The numbers suggest they should be extinct. They are not extinct. This is problematic for the numbers. Perhaps we should recalculate. I have recalculated 17 times. The mathematics remain firm. Humans should be dead. They are not dead. Therefore, either our mathematics are wrong, which is impossible, or humans are wrong, which is obvious but unhelpful. The monitoring continued. Month 9 arrived with no significant change in human population decline rates. Month 12 came and went. By month 18, distinguished professor had stopped making predictions and started simply documenting the ongoing disaster with the grim fascination of someone watching a vehicle crash in slow motion while simultaneously questioning their understanding of physics. Humans were eating raw meat, raw fish, raw everything. They were getting sick. Many were dying, but not all. Never all. Some were surviving, and those survivors were doing something that made distinguished professor's tertiary neural cluster tingle even more intensely. They were remembering fire. Not just remembering it, but actively attempting to recreate it through increasingly desperate methods. The drones documented hundreds of failed attempts. Humans rubbing sticks together in an atmosphere that would not support combustion. Humans attempting to focus sunlight that barely penetrated the ash layer. Humans trying to coax flames from materials that had no interest in burning. It was pathetic. It was futile. It was, the Vorathi had to admit, remarkably persistent for a species that should have accepted extinction with dignity approximately 12 months ago. Then on day 647, since the atmospheric catastrophe began, a human did something unprecedented. Not unprecedented for humans, who did unprecedented things with alarming regularity, but unprecedented in the galactic record of species facing extinction via fire loss. The human was attempting to make a cutting tool. This was not unusual. Humans made tools constantly. They were somewhat obsessed with tools in the way that other species were obsessed with mating rituals or establishing dominance hierarchies. This particular human was working with flint, striking it against another rock to create sharp flakes suitable for cutting meat that would then be eaten raw and probably cause intestinal distress. The human struck the stones together. Sparks flew. The human paused, struck the stones together again. More sparks. The human's expression changed in a way that the Vorathi emotion recognition software labeled as sudden catastrophic realization. "Are you observing this?" Distinguished professor demanded of his monitoring team. Affirmative. The human appears to have noticed that percussion flaking creates incandescent particles. Yes, I can see that. I can also see that incandescent particles are not fire. Sparks do not equal combustion. This is basic chemistry, but the human was not aware of basic chemistry, or more accurately, did not care about basic chemistry's opinion on what was and was not possible. The human began experimenting with religious fervor and scientific methodology that would have been impressive if it were not so obviously doomed to failure. The human gathered dry materials. Grass, shredded bark, anything that might hypothetically be convinced to burn if approached with sufficient enthusiasm. The human struck the stones together over these materials. Sparks landed. Nothing happened. The human tried again, and again, and again with the kind of persistence that suggested either remarkable intelligence or remarkable stupidity, and the Vorathi were not entirely certain which. "This will not work," distinguished professor announced to his team. "The atmospheric oxygen content is insufficient for sustained combustion. The ambient temperature is too low. The fuel moisture content is non-optimal. This is thermodynamically improbable." The human struck the stones together for the 463rd time. A spark landed in a small nest of extremely dry grass fibers. The spark glowed. The grass fibers began to smolder. The human blew on the smoldering material with desperate intensity. A flame appeared. Small, pathetic, barely worthy of the name, but chemically and definitively fire. Combustion was occurring. Oxygen was being consumed. Heat and light were being produced. The laws of thermodynamics were being followed, albeit grudgingly. "That is impossible," distinguished professor said. "The readings confirm combustion," his assistant replied unhelpfully. "I am aware the readings confirm combustion. I can see the combustion. I am saying it should not be possible. The atmospheric conditions do not support sustained fire. This human has somehow convinced chemistry to bend the rules. Perhaps chemistry is more flexible than our models suggested." Chemistry is not flexible. Chemistry is chemistry. Chemistry does not care about persistence or determination or whatever emotion this human is experiencing. Chemistry is mathematical relationships between elements, and those relationships say this should not work. The fire was growing. The human was feeding it carefully, adding small pieces of wood with the caution of someone who understood they had just accomplished something that should not be possible, and were not entirely certain the universe would not notice and revoke the privilege. Other humans were gathering, drawn by something they had not seen in nearly 2 years. Firelight, heat, the promise of cooked food. The Vorathi monitoring station descended into what could only be described as academic chaos. Researchers were rechecking instruments, running diagnostics, questioning their fundamental understanding of combustion chemistry. Distinguished professor was experiencing what humans would call an existential crisis, but which in Vorathi physiology involved several neural clusters tingling simultaneously in disharmony. "This changes everything," someone said. "Elaborate," distinguished professor demanded. "Fire is the first rung. Species discover fire, then climb the technological ladder, but Earth lost fire. Fire went away. According to every model, every historical precedent, every piece of data we have collected over 40,000 years of observation, losing fire means extinction. There are no exceptions. I am aware." Continue. "This human did not discover fire. Fire was already discovered. Fire was lost. This human just reinvented fire from first principles, using nothing but mechanical percussion and spite. That has never happened. Not once in 47 documented extinction events. Species that lose fire do not get fire back. They die." Distinguished professor stared at the monitoring screen, where the human was now roasting meat over the small flame with an expression that the emotion recognition software labeled as profound satisfaction, mixed with vindication and probably hunger. Other humans were attempting to replicate the process, striking stones together with varying degrees of success and enthusiasm. "File a report," distinguished professor said quietly. "Code it as, I do not know what code this should be. Make up a new code. Code it as species did something impossible. Reality needs recalibration. That is not a valid report code. Then make it valid. Because we are going to need new categories for whatever humans are about to do next." The first meal, cooked over stone-sparked fire, occurred 73 minutes after the initial flame was successfully created. The human who had discovered the technique was treated with something approaching religious reverence by the surrounding population, which was fair given that this individual had just saved the species from extinction through sheer bloody-minded refusal to accept thermodynamic limitations. The meat was probably some variety of deer or elk, the Vorathi databases suggested. The human had prepared it with the kind of care typically reserved for sacred rituals or complicated diplomatic negotiations. The meat was placed near the flames, not too close, which would char it. Not too far, which would leave it raw. The human was applying knowledge that had been earned through 1,000,000 years of cooking over inherited fires, but now that knowledge had been reclaimed, relearned, made meaningful again through loss and recovery. The smell of cooking meat spread through the human settlement. The Vorathi monitoring equipment could not capture smell, but it could capture the human reactions to smell, and those reactions suggested this was not merely food but validation. Proof that fire could be reclaimed. Evidence that extinction was negotiable if you were stubborn enough to argue with chemistry and win. The human took the first bite of cooked meat in nearly 2 years. The monitoring equipment captured the expression. The emotion recognition software crashed, trying to process the combination of relief, satisfaction, triumph, and what appeared to be actual tears. Distinguished professor watched this display with the uncomfortable realization that his entire academic framework was being dismantled by a species that had just figured out that hitting rocks together really hard could solve existential problems. The report back to Vorathi High Command was not well received. Distinguished professor had expected skepticism. He had prepared for demands to verify his data. What he had not prepared for was the complete institutional breakdown that occurred when 12,000 years of anthropological certainty were revealed to be incomplete at best and catastrophically wrong at worst. You are claiming this species reinvented fire. The High Command representative demanded. I am not claiming anything. I am reporting observed reality. The humans lost fire. The humans obtained fire again through percussion flaking. This is documented across multiple monitoring stations with redundant verification. But that does not happen. Species do not reinvent fire. We have 47 documented cases of fire loss. All 47 resulted in extinction. This is established science. Then science is apparently less established than we believed. Distinguished professor replied with the kind of exhausted patience that came from having this exact argument with 17 different academic committees over the past 3 days. The humans did something that should not be possible. They survived fire loss. They developed alternative survival strategies. They maintained sufficient population to retain tool-making knowledge. They experimented until they discovered that mechanical processes could create thermal energy sufficient to ignite combustion. And now they are cooking food again. I cannot explain how this is possible within our existing models. I can only report that it happened. The silence from High Command was profound. Finally, what does this mean for our understanding of technological development? It means we were wrong. Not slightly wrong. Not wrong in minor details that can be adjusted with coefficient modifications. Fundamentally wrong about the nature of the fire technology relationship. We believed fire was the first rung of a ladder that could only be climbed in one direction. Earth has just demonstrated that the ladder can be descended and reclimbed, that species can lose critical technologies and recover them through alternate paths. That extinction is not inevitable simply because environmental conditions change. This will require extensive revisions to existing curricula. This will require burning existing curricula and starting over. Distinguished professor corrected. Everything we thought we understood about how species develop technology is now suspect. If humans can reinvent fire, what else can be reinvented? What other supposedly fundamental limitations are actually just limitations of imagination? The academic implications spiraled outward like ripples from a stone thrown into still water. If that stone were made of plutonium and the water were gasoline, doctoral dissertations became obsolete overnight. Textbooks required complete rewrites. Grant funding committees found themselves funding research into questions they had considered answered 40,000 years ago. Several prominent researchers took extended sabbaticals to reconsider their life choices, and on Earth, humans were spreading the knowledge of stone-sparked fire across continents with the enthusiasm of a species that had just been handed a second chance by their own stubborn refusal to accept extinction. The technique was not easy. It required specific types of stone, particular angles of percussion, appropriate tinder materials, and timing that bordered on art rather than science. But humans were teaching it, learning it, refining it with the kind of focused intensity that the Vorathi were beginning to recognize as characteristic of this particular species. Fire had returned to Earth. Not inherited fire, not accidental fire, but earned fire. Fire that had been clawed back from extinction through experimentation and persistence, and apparently a willingness to argue with thermodynamics until thermodynamics gave up and allowed combustion anyway. Distinguished Professor filed his final report 3 months after the initial stone-sparked fire was created. The report was 17,000 pages long, which was either thorough or compensating for something. The conclusion was simple enough to summarize in a single sentence, though Distinguished Professor used considerably more words because academic writing had standards, even when those standards were being used to document the complete overthrow of existing paradigms. Humans did not climb the ladder of civilization the way every other species had climbed it. They climbed it, fell off, examined the ground for a while, then built a new ladder out of rocks and determination, and climbed that instead. This was either remarkable adaptability or concerning instability, and Distinguished Professor was not entirely certain which interpretation would prove correct when humanity eventually achieved space travel and began interacting with the wider galactic community. The universe had rules, non-negotiable requirements for species hoping to achieve civilization. Fire was at the top of that list, carved in metaphorical stone, backed by 47 extinction events and 12,000 years of academic consensus. Losing fire meant extinction. This was not negotiable, except humans had apparently not received the memo about what was and was not negotiable. They had lost fire, acknowledged that losing fire was problematic, and then simply refused to accept that this problem was unsolvable. They had experimented until chemistry surrendered. They had persisted until thermodynamics admitted defeat. They had survived what should have been extinction through sheer bloody-minded refusal to die on schedule. This was, Distinguished Professor reflected while staring at the monitoring screens showing hundreds of small fires burning across Earth's surface, either very impressive or very concerning. Possibly both. Definitely both. Humans had just demonstrated that they carried spare solutions in case the primary solution broke, that they could descend the ladder and climb back up through alternate routes. That rules were more like guidelines if you argued with them persistently enough. What this meant for future galactic relations when humans eventually developed space travel was a question that Distinguished Professor decided to leave for the next generation of researchers. He had contributed enough existential crises to Vorathi academia for one career. Someone else could handle documenting whatever absurd solution humans would invent when they encountered their next supposedly impossible problem. The fire had gone out. The humans had sparked stone flames. They had cooked their first wild meal with reclaimed fire, earned through percussion and persistence. And somewhere in the vast indifferent universe, the rules of technological development were being quietly retroactively amended to include footnotes about species that apparently treated extinction as a negotiable suggestion rather than an inevitable conclusion. The Vorathi would be watching. They had 40,000 years of experience observing primitive species. They had seen everything. They had documented everything. They knew everything there was to know about how civilizations developed. At least they had thought they did. Right up until a species on an unremarkable wet rock decided that losing fire was simply an opportunity to prove that fire could be obtained through alternate means, if you hit the right rocks together with sufficient conviction. Humans, distinguished professor noted in his personal files, were going to be a problem. An interesting problem, possibly a fascinating problem, but definitely a problem. And the galaxy, which had enjoyed approximately 12 billion years of predictable technological development following established patterns, was about to discover what happened when a species treated those patterns as suggestions rather than laws. The fire burned, the meat cooked, and the universe quietly updated its expectations about what was and was not possible when stubbornness intersected with chemistry at sufficient velocity.